Jon from Supabase here, and in this video we're going to learn all about Postgres Functions. Now, functions in Postgres are just like functions in any programming language. They allow us to take a collection of statements and bundle them together and then abstract them away, so we don't need to think about them anymore. Then anywhere in our code we can call that function rather than copying and pasting that potentially complex logic everywhere throughout our codebase. This obviously makes our code a little bit more maintainable, as if we want to add additional statements to our function, we only need to do it in one place, and then that will flow throughout our application. But this can also give us some performance benefits. Because these functions are stored in the database itself, it means that if we need to transform the data to display it in the client, we don't need an API to overfetch a whole bunch of results, do that data transformation, and then just kind of throw away the bits that it's not using. The database can just extract and transform the data into the exact state that the client needs and just send it back. So let's have a look at how we can create Postgres functions with Supabase. Here I have a Supabase project called Neighborhoods. And so this is just a system I'm building to get to know my neighbors. We have two tables in this project, so a resident and a street. A resident has a name, they have which number on the street they live on, and then they have an ID for the street table, which we can use to look up the name. And so in our street table, we have Billionaire Lane and we have McMansion Avenue. So back in our resident table, we have Kanye West, who's living at number 36 Billionaire Lane. And then Jay-Z and Beyonce are living together. I guess they have 99 problems, and most of them are probably Kanye West. And then DJ Khaled is living all by himself on McMansion Avenue. He did have some neighbors, but then one left, and then another one, and then another one. And then he looked up and was like, I'm the only one. Okay, so let's have a look at how we could use Postgres functions to manage some of the data in our project. So if we come over to the SQL editor here and we go to query 1, we can create a function by saying create or replace, and then we use the function keyword, and then we can give our function a name. So here we can say hello, and we declare any parameters that we're going to pass into our function. So the reason we're using create or replace here is because this makes this statement what's called idempotent. And so that just means that we can run it over and over and over again and we'll get the same outcome. And so no matter how many times we run this statement, we could run it 20 times and we'll still just have one function called hello. Now we need to declare what data type our function is going to return. So we can say returns text, because we're just building a simple function here to return the text hello world. And then we say as, we do $2, and then we leave us some lines and do another $2, and then we need to tell it which language we're using. So here we're going to say language SQL. So there are a whole bunch of languages that you can use to declare functions in Postgres. We're using SQL here, and then later in the video we'll be looking at a procedural language in Postgres. But if you're more comfortable with JavaScript or C or Java or anything like that, there are a range of different languages that you can use to write these functions. So now anything between these $signs and these $signs is going to be the body of our function. And so this is what's actually going to execute when we call or invoke this function. So if I want to return the text hello world from here, I can do that by using a select statement and then say select the string hello world. And so now if we want to run this statement, which is going to create our function, we can click the run button down in the bottom right here. And so we get the message, success, no rows returned. And so this is good. Anytime you don't get an error in SQL, that means everything is all good. So now if we wanted to call our hello function, we can create a new query, and we can again use a select statement and then the name of our function. So in this case, hello, open close brackets, and we can give it a semicolon, and then we can click run again. And that's going to call our hello function, which returns us the text hello world. Okay, cool. So in the body of our function, we can run any kind of SQL that we wanted. And so what if we wanted to create another function that could just select all of our residents for us? So the first thing we would do is rename our function. So this one's going to be called getResidents. And then rather than returning just one text value, we probably want to return a collection of our residents, so each of our resident rows. And so for this, we can say we want a set of resident. Okay, so now we can replace our select statement here with a select star from resident. And now we can click run to create our function. And so again, if we wanted to call our function, we just come over here and change hello to get residents. And if we run that statement, we will get back a list of all of our residents. But now the cool thing here is because we're actually getting back a set, we can treat this just like any table in SQL. So we could say select star from this function, and then we can get back each of those columns. So we have ID, name, street number, and street ID. And so then if we just wanted to get back the name, and so now our result set only contains that name column. And so we can even chain on more things to our select statement. So we could say select name from get residence where their street ID is equal to 1. And so now when we run this query, we'll only be getting our results from the people who live on Billionaire Lane, and DJ Khaled has dropped off that list. And so this is cool, but what if we wanted to group together some more complex logic? What if we wanted to create a new function called addResident? And this function could take in the name of our new resident, it could take in their street number, and it could take in their street name. And so this might just look like a simple insert statement, but name and street number exist on our resident, whereas our street name exists in our street table. And so we're going to have to do a lookup for the ID that's associated with this street name, and then create a new resident with our name, street number, and street ID. And it would be super convenient if every time we add a new resident, we could give them back a list of all of their other neighbors, so anyone else who lives on their street, with their names and street numbers, so they can go knock on some doors and introduce themselves. So let's start building our function. So the first thing here is we're going to replace the name with addResident. And this is going to take in our parameters. And so we had a name. I'm just going to append each of our parameters with the word input, just so that we can help distinguish between those and the columns in our statements. And our name input was of type text. Our street number input was of type int. And our street name is of type text. Now this is still going to return us a set of resident. So that is all good. But the language here, because this is going to be a little bit more complex, we are going to use the procedural language that we get with Postgres, which is called PL for procedural language, and then PG for Postgres, and then SQL. So PL, PG, SQL. And so this is basically going to give our SQL superpowers. And so we will have the ability to declare variables and write if statements and while loops and things like that. And so the body of our function will still be between the two $signs. The only difference is when we're using PL, PG, SQL, is we need to wrap our body in a begin and end. So the first thing we want to do is look up the ID that's associated with our street name input. We then want to insert a new row into the resident table with those values. And lastly, we want to return our new resident a list of all of their neighbors. And so we want to select all of the residents that live on the street, except for our new resident, obviously. Okay, so let's start by selecting the ID column from our street table, where the street name is equal to our street name input. Great, so now we have our street ID, but we need a way to pass it into our insert statement. And so each of these statements is going to execute sequentially, but they each have their own scope. And so this insert statement can't reach in and grab the ID from this statement because they exist in different scopes at different times. So the only way that we can provide access to this value is by storing it in a variable that's in scope for all of these statements. And so this is something special that PL, PG, SQL gives us, where we can actually declare variables. So we do that by adding a declare section above begin, and then in here we can have a list of all of the variables that we want to create. And so in this case, I'm going to have an s_id, which is of type integer. And so then we can use that variable in our select statement by saying select id into s_id. And so then that's going to take that street ID and store it in a variable that's available to us in our next insert statement. So let's insert a new resident record. And then our values are going to be name input for our name column, street number input for our street number column, and then our variable s_id for our street ID. Awesome. And so now for the last part of our function, we just want to select all of the other neighbors. And so we could use our getResidents function here. And so that's going to get us all of the residents, and then we can add a where clause for where the street ID is equal to our s_id variable. And we also want to exclude our new resident. And so we can say and not name equals name input. Awesome. And so now we just want to return this result set from our function. And so here we can say return, and then we just need to add the keyword query to say we want to return this select query. Okay, there was a lot that we just went through there, so maybe let's just review our function here. We're creating a new function called addResident, which takes a collection of parameters. We then declared a new variable, which we can use to store a variable that's available to all of our different statements. We looked up the ID for the street based on the street name input that we were given, and then we stored that value in our variable. And then we used our name input and street number input along with our variable to create a new resident. We're then returning all of the people who live on that street except for our new resident. So let's click run and hope we haven't messed anything up. Awesome, so that was successful. Now let's go and actually call our function to create a new resident. So Cardi B is going to move in, and she's moving into number 11, Billionaire Lane. And then we want to get back all of the columns from our addResident function. And now when we run that function, we get back Kanye West, Beyonce, and Jay-Z, our wonderful new neighbors. And if we go over and look at the table editor, we can see that Cardi B has been added to our resident table. And so we can combine all of these little bits of separate logic into this quite complex function. And then all that the client actually needs to provide us is just these 3 values. And that's how easy it is to create Postgres functions using Supabase. Now we're going to release a couple of related videos to really show you the power of Postgres functions. The first one is going to show you how you can call Postgres functions from your client using JavaScript. Then we want to show you how you can set up Postgres triggers to automatically call your functions anytime data in the database changes. So we'll update the description with links to those videos once they're ready. But in the meantime, why not check out our channel on YouTube for more awesome videos just like this one? Give us a follow on Twitter and check out our Discord. We'd love to hear what you're building with Supabase. Thanks for watching.